Now take a look at these two road signs. Here we've got a car heading down a hill, and here we've got a truck heading down a hill. Now it looks as though they're heading down pretty steep hills, doesn't it? And the steepness is determined by this angle. The angle between the flat line here, what we call the horizontal, and the surface of the hill, the roadway, which is here. Between any two straight lines, let's see if I can draw a straight line, that's one, and here's another one, I'll do it horizontally, is an angle. So what does that mean? It means that this is an angle just here, this is an angle, and this is an angle, and this here is an angle. Now, this angle is much bigger, is much wider, if you like, than this angle. And the wider this angle is between the roadway, let's just draw one over here. I suppose that's a road on the side of a hill, and this is the flat. My lines are pretty bad. This is the flat area. The bigger that angle is, the steeper the hill, as we say. So there's quite a steep hill. Here's a very steep hill indeed. We'll say that's a very steep hill. Why? Because that angle here is bigger than that angle here. And let's do a really, really, really steep hill over there. I tell you, I wouldn't like to drive down that one. It wouldn't be a matter of driving, really. It would be a matter of falling. Now that's so steep because that is really, really huge. Now let's take a look at this road sign here, the one with the truck going down it. Now you see what it's got under there? It has written 8, and this sign here means percent, 8%. Now what does that 8% on this sign, what do you think that means? Well, first of all, what is 8%? Well, 8% means 8 hundredths. That's what percent means. Per cent, cent like in US cents, pennies, is 100. 8 per 100. 8 in 100. Now what does that mean in the context of this road sign, for goodness sake? Well, it's real simple. I'm going to suppose that this is a green hill. There, that's a bit green. Okay, and the truck is heading down it, heading down the grass rather than the road. And this, let's suppose, is the horizontal. This is the flat bit here. This 8% means that for every 8 that the truck goes down, it goes along 100. So if that's 8 down, then it goes along 100, because 8% means 8 1 out of 100. 8 100ths. An 8% drop means that for every amount that it goes down 8, for every 8, whatever it happens to be, every 8 feet, or whatever it happens to be, it goes along 100 of the same units, 100 feet, or whatever the case is. In fact, that's a lot steeper than 8% actually, isn't it? What is this? Well, that's about 1 and that's about 2. So let's suppose it's 1 down and 2 along. 1 down and 2 along. What is that in terms of percent? If that were the slope of the hill, what would we see on a road sign indicating in percent the slope of the hill? Well, it would be 1 down over 2 along. That's a half. What's that per 100? Well, how many 2's go into 100? 50 do. So we multiply that by 50 and we get 100, and we multiply that by 50. That's a 1, and we get 50. So that's 50%. So over here, we would have, on that slope, on that basis, that would be a 50% slope. Well, what about this one over here? Let's just take a look at that. Boy, this is a really steep hill. How many? We're probably going down here about 2 for every 1 we go along. If we come down there. Boy, if we were on there, we would shoot down that hill like a rocket, wouldn't we? Because it's so steep. As I said, it's not really driving down the hill. Let me draw a car here. And it'd have to be a pretty fast car because it would be going pretty fast. And there's a person inside there, and that's all their hair being blown back as they rush at a gazillion miles an hour down that hill. Anyway, they're going down for every 1 they go forward. Now what's that? That's 200%. 2 down for every 1 across. So for every 100 across, multiplying by 100, we've got to do the same up here. It's 200. That's 200% incline. 200%. Now, you're beginning to see, I take it, a pattern. The steeper the hill, the higher this percent. That's quite a steep hill, 50%. That's a really steep hill at 200%. And actually an 8% hill would be 8 down. Let's see if I can draw it more there. And it would kind of be more like that, wouldn't it? 8 down and 100 across. So that's an 8% hill. So the angle here is related somehow to this number here. Now actually what we have is an expression which we call tangent. I'm just going to write it over here. T-A-N-G-E-N-T. And the tangent of an angle, let's call this angle A. Well, I'll do it with this one. Let's call this angle A. The tangent of the angle A, and let's shorten tangent because it's quite a long word to write, isn't it? So we'll say tan angle A is equal to, in this case, 200%. 200%. And another way of writing 200% is 2 over 1. 2 divided by 1. And 2 divided by 1, how many 1s go into 2? Well, 2 do. So that's another way of saying that's 200 divided by 100, and that's simply 2. So the tangent of this angle is just the drop by the number of units along. Tan of A is 2. What's tan of this angle? Let's call this angle B. What's tan B? Well, by the same token, tan B is equal to the number of down. How many is that? That's 8 divided by the number of across units. That's 100. Now what's 8 divided by 100? Well, if we do it in decimals, it's 0.08. Okay, now let's just express this a little bit more generally. And let me draw another angle over here. These are supposed to be straight lines, by the way. That's across and that's straight up. Now bear in mind that if that's across and it's flat and that's straight up, what's this angle here? Well, it's a square angle, isn't it? It's what we call a right angle. So if we have, what is this then that we've got here drawn in blue on the outside? That's a right angled triangle. That is a triangle because there are 3 angles. There's that one, and there's that one where these lines cross. And so it's a triangle, and there, moreover, one of the angles is a right angle, a square angle, that one here. So it's a right angled triangle. And if we have an angle here, now sometimes we give funny letters to angles, and let's give this one a funny expression. We're going to give it what's an ancient Greek letter. Now, I don't know whether you know anything about ancient Greeks, but the ancient Greeks, well, they were always fighting among themselves and philosophizing, and they had republics and all this sort of stuff, and then they were going off on adventures to exotic places, and they were fighting battles, and they did all of that stuff about 3,000 years ago. And they had an alphabet. It wasn't our alphabet like A, B, C, D, E, F, G. The Romans invented that alphabet, but they had a Greek alphabet, and they had all funny letters. And I'll just draw a bit. The first letter of the Greek alphabet was alpha, which was drawn like that, and then there's beta, like that, and then there were others like gamma, and so on and so forth. Now, one of these letters that we typically, in this Greek alphabet, that we use often to signify angles is this. It's like this sort of O, well, really a zero with a line across the middle, and that's called theta. So we're going to call that angle theta. I'm just going to draw that here. So what we can say here is the tan of that angle theta, tan theta, is equal, let's give these sides of this triangle names. We'll call that, actually that's the height of the triangle, isn't it? So I'm going to call that H. And then this is a long, and so how do I do that? I'm going to call that L. L, and this is the slope, and I'm going to call that one S. So tan theta is equal to what? It's H over L. It's the down, which is H, divided by the across, which is L. Tan theta is equal to H, in this case, using this terminology, over L.